special edition of The Sky at Night.
Good evening and welcome to my home in Selsey and a very special Sky at Night programme, the 700th, the longest running television programme in the world. This programme is dedicated to answering questions you've sent in. And with me are friends of the Sky at Night, old and new.
Well, I grew up with the Sky at Night. It is one of the reasons that I became interested in astronomy and physics. I had no idea I'd be on the 700th programme. I had no idea I'd be on any programme. So it's wonderful for me.
Well, I'm not an expert, but I'm very much an enthusiast, and it'll be my job to read out the viewers' questions, be the voice of the viewer for the gathered panel of experts on the programme. And, well, there's been one or two occasions when I've put myself in Patrick's shoes.
Good evening. Now, what I want to do in these talks is tell you about some of the interesting things you can see in the night sky each month.
Well, I've got to know the Sky at Night viewers over the years, and they're always sharp. They never let us get away with anything. So whatever questions they've asked, they're going to keep us on our toes.
Once a month, Patrick's home in Selsey becomes home to the Sky at Night. Today, we're turning his dining room into the set for this special programme. Astronomers are dropping in from all over the UK.
Hello, Patrick. Yeah, we've met before.
We met a bunch of years ago. How are you?
The Sky at Night viewers have sent us over 1,000 questions, and the experts are here to answer them.
Patrick.
Yes. Hello.
Hello. Nice to see you again.
First up, Professor Alan Fitzsimmons for your questions on the solar system.
Welcome to everybody. Glad to see you here. Right, take our first question.
Here it is from John A. Tompkins of Skelmersdale. If all the planets in the solar system were formed from the same cloud of material by a similar mechanism, why are they all so different, in particular Saturn?
Well, of course, we've got 8 planets, or at least now we have 8 planets in the solar system. And we can, first of all, split them up into 2 groups. We've got the rocky planets that are closer to the Sun, Mercury, Venus, Earth and Mars. And then further out, we've got the giant planets, Jupiter, Saturn, Uranus and Neptune. Yeah. We think what we're seeing there is kind of a relic of the time when the planets formed, because when the planets were forming, coming together from the disk of material swirling around the Sun itself was also forming. And in its very early days, it went through a very energetic phase. And during this phase, the star is very luminous. It emits copious amounts of energy. And that has a dramatic effect on any disk of material surrounding it. The material closest to the star is simply swept out of lighter elements. So if a planet's forming, the rocky elements, the heavy elements, can stay there and they can form the planet, but there's not much gas left around to form the atmospheres. Whereas further out in the solar system from the star, there's much more gas left there, and that can accrete onto the forming planets, and they become giants, the giant planets that we see today.
But we've seen some exoplanets, so planets around other stars, haven't we, where there are these Jupiter-sized planets are bigger, very close to the stars, these so-called hot Jupiters.
Which sort of destroys this beautiful theory.
How does that fit in, that you can get a gas giant very close to a very luminous star?
Well, what we think is we still think the gas giants form out at some particular distance from the star, but they don't stay there. In fact, there's evidence in our own solar system that after the formation, the planets moved. Not only the giant planets, but also the inner planets, such as the Earth.
Planetary migration, in fact.
Absolutely, and planetary migration is what we believe it explains the existence of these hot Jupiter-type planets close to their parent stars.
There's certainly one idea. Right, can we go on to question 2, John?
Well, I was just going to ask one thing. Sometimes you hear Jupiter described as a failed star. And is that right?
Well,
no.
Well, no. We believe stars and planets may form differently. A star is purely gas. It's the condensation of a nebula all coming together and reaching such tremendous pressures and temperatures in the centre that nuclear fusion starts. At one time, it was thought maybe Jupiter was like that as well, but we now believe it has formed possibly the same way as the other planets. It's got a rocky core, somewhere in the centre of Jupiter there, but it's probably a rocky core, perhaps even the size of the Earth. So it's still right to call Jupiter a gas giant because it's pretty much gas all the way down. But at some point, you might hit a rocky surface.
There's a surface there somewhere.
Somewhere, yes. You probably don't want to go there, though.
Well, fine, so let's go on, Joshua.
Right, now then, this is from Luke Butler, aged 11, from High Wycombe. Is there a heaven? And if so, which planet would it be on?
Oh.
Well, I'll steer clear of the theology, but I think the place where I'd most like to be in the solar system, I think sitting on the surface of Europa, watching Jupiter in the sky, which would be sort of this sort of size, and just watching sitting there. I'll have something to keep me warm. I'll have a source of food sent from Earth, please, and a bar. And I'm just going to sit back and I'm going to watch the weather on Jupiter. And plenty of ice. Yeah, I've got the ice, so that's fine. So that's mine. Where would you be,
I'll
Patrick?
go for Iphitus, Saturn's eighth major satellite, because you have a lovely view of the rings from there, and a nice view of the sky as well. Interesting world, yes. Give me Iphitus.
OK, that's fine. So you've got one of Saturn's moons, I've got one of Jupiter's. Alan?
OK, I'm going to wimp out of the theology question as well, but...
We all are.
I'm going to plump for here, because I find all the planets and all the moons and all the bodies in our solar system fascinating. But I don't think any of them are quite as beautiful as our planet. And heaven is supposed to be beautiful, so if it exists, it's got to be here. And
heaven is a place on Earth.
Absolutely, yes.
Yes, I know. It's called Selsey.
Excellent. Good.
I must say my favourite picture in the history of space exploration is the pale blue dot picture, which Carl Sagan asked Voyager to take, famously, from, I think it was beyond the orbit of Neptune. So that's the Earth just as one pixel in a sunbeam, suspended in a sunbeam. It's very close to the sun from out there. So I might go for that view beyond the orbit of Neptune, so I could see my own pale blue dot picture with my own eyes.
I think Pluto as well, where you'd see the sun at that great distance and its moon Charon sort of dominating quite a lot of the sky. That would be enormously peaceful, I think, and just to survey the entirety of the solar system would be rather nice.
Fair enough. So we've spread out amongst the solar system between us.
Either that or Gallifrey.
Well, Alan, thank you very much indeed. Been great to have you back, and come back again soon.
It's over 80 years since Patrick first used his telescopes to look at the moon and the planets. He's recorded everything he's seen in minute detail. Astronomer Paul Abel has been going through Patrick's logbooks to show Jon some of the more unusual observations.
One of the wonderful things about being here is that every room is so richly full of archives. And
it is. This is my favourite room.
This is your favourite room?
This is the slide room. It's just filled with recordings going back to the 60s. But this is the shelf for me. This is where all of Patrick's observing books are kept.
His very own observing books where he would record his own observations. Oh, here's a great example.
This is a good one. This is Saturn.
The Saturn book.
There's a nice story attached to this and this particular era. When Saturn was edge on, see these little dots here?
Yes.
These are the satellites of Saturn. This was a time when the rings were almost edge on. And Patrick recorded a dot that shouldn't have been there, and later on he realised that was the satellite Janus. It was discovered, he recorded it, but didn't know he had recorded it, and so was robbed of this great discovery.
Oh, that's Sir Patrick's there. That's his discovery.
It's this little discovery, yeah, it's brilliant.
Nice description just there. By the time I got home, Jupiter was treed out.
Treed out turns up a lot. Jellyfish seeing turns out a lot.
Okay.
And this mysterious Spode's law, which when everything goes wrong, Spode strikes again is what...
Spode's law.
Yes, or Spode has set up his HQ on Saturn tonight. That's another one I've read.
This is wonderful here. Odd things went on. We eventually persuaded the dome to move the right way, but periodically, motors whirred, mysterious lights flashed on and off, the platform creaked alarmingly, and on one occasion there was a small fire in the telescope pillar due to a short circuit. These things happen. Naturally, the driving clock went on strike, but we managed.
It's brilliant, isn't it?
Yes, if you're going to have a disaster, at least record it with some wit.
He
just
does.
like that.
All good stuff. Back to more recent times, what we now know Patrick's fairly famous for, of course, is the moon.
Oh, indeed.
One of the things he did actually discover is the crater Einstein. One of the things he used to do back in the 50s and 60s was look at the limb of the moon, the extreme edge, because as you know, the moon wobbles on its orbit around, so sometimes you can see stuff that's on the far side. And one night Patrick did manage to pick up crater Einstein and made the discovery.
Now, was that the feature that was later rediscovered by the Americans?
No, that's the Mare Orientale, and in fact that was discovered by a German chap before Patrick and the Americans. Don't tell Patrick.
Patrick discovered it properly.
He did. He puts in the mistakes as well. There's in the solar book, he's observing the sun. He says, wonderful view of the sun. Would dearly love to carry on observing. Alas, I have locked the keys in the observatory. Why put that in?
Oh, it's a nice moment that would just remind you of
Pure
the observations that day, yes.
Well, look, there's a very young Patrick Moore with his telescope.
1952. Yes, the sky at night hadn't been thought of at that time.
It's time for our next guest, Dr. Lucy Green.
Hi, by the way.
Oh, hello, Lucy. Nice to see you.
Nice to see you too.
She studies every flicker of the sun, our nearest star.
Well, let's have our first question about this.
And thanks to Bart van der Putten from Amsterdam for this one. Who was first to realise that the sun was just another star, like the thousands visible in the night sky?
I wasn't there.
And I don't have any clue.
Lucy.
Well, I thought that was a really nice question because it's about making that mental leap, isn't it, about what our local star is. And I could track it back as far as the 16th century and an Italian monk come philosopher called Giordano Bruno.
Oh, yes.
And so he's quite famous because he was also interested in an infinite universe and plurality of worlds. And he thought that, in fact, the other way round, stars are the same as our sun, but they're just much, much further away. But then we can kind of go one step further than that, because to really be able to say that the sun and the stars are all the same thing, you need spectroscopy. So with the developments of spectroscopy in the 1800s and 1900s, that gave us the techniques and the physics to be able to say confidently, yes, the sun and the stars are all the same kind of object.
Thank you, Lucy. Yes, next question.
OK, this from John Moore from Peterborough. Solar prominences are huge, but on what timescale does a prominence actually occur? A minute, an hour, a day, a year, or more?
Yeah, so prominence is one of the most beautiful phenomena on the sun. I mean, absolutely amazing. And they are gigantic. They stretch for hundreds of thousands of kilometres, and they're beautiful. And they don't take that long to form, actually, considering their size. So over maybe a day, you'd get a prominence forming. And you can look at them in hydrogen alpha and see them forming over this time. So once they form on the sun, they can last for week after week after week, and then suddenly erupt when we least expect
So
it.
why do they suddenly erupt? What causes the sudden change?
Well, it's to do with the magnetic fields. So the structures are formed because of a magnetic configuration that can hold the material in place. And the magnetic field evolves and it can destabilise. And at that point, the structure erupts into the solar system.
That's interesting. Could you think of them? I thought of them actually as explosions, but you're saying they're not really. It's a magnetic field effect first, and then the material follows the reconfigured.
That's right.
field.
So I think about solar flares in terms of an explosion, but a filament eruption or a coronal mass ejection is different. It's just a lifting off of the material because of forces in the magnetic
They're
field.
certainly lovely to observe.
They're beautiful.
Is it true that the sun becomes 4 million tonnes lighter every second?
That's right, because of the fusion happening in its core.
Listen for a moment.
Yeah.
Between those two taps of my hand on this glass table, the sun lost 4 million tonnes. Don't worry, there's plenty left. Oh, thank you, Lucy.
We've had many questions about telescopes. Over the years, the Sky at Night has often featured Patrick's own observatories.
And it's from this dome, with this telescope, that I've spent a lot of time in the last few months looking at the planet Mars. This is my new one. I can't resist showing it to you. This is my 15.5-inch reflector, and you can see it's pretty massive. I have my own observatory at Selsey, where things don't always go according to plan. flaming thing struck.
Astronomer Pete Lawrence frequently uses Patrick's telescopes, and he took John on a tour.
I think this is the first time I've seen Patrick's garden during the day.
Do you know, that's a good point. I haven't been here many times during the day. Well, this is Patrick's 5-inch Cook refractor. Have you ever seen it?
I have never met this telescope before.
You're in for a treat now then, John.
Oh, let's have a look.
I'll let you go in first.
Here we go.
I'll just take the roof off here, John.
OK, let's take the roof off.
A roll-off roof. You can see it's got this amazing bicycle chain arrangement here.
Look at that, wonderfully mechanical.
It is.
Like a Wallace and Gromit invention, isn't it? We can see it working like that.
And unlock the telescope. And there it is, ready to be used.
So if you've a telescope as big and as powerful as the one just across the way, why would you need one like this, which appears smaller and less powerful?
Well, I think they all have their own sort of area where they excel, really. This one's particularly good for planets.
Rather fond of these antennas too here like that.
These are the slow motion controls, so that if you line up the telescope with the finder, you can use these just to fine-tune the position of it.
I haven't broke it by doing that, have I?
So,
good.
So this is the 5-inch. Shall we go next door and have a look at the 15-inch
I think we should, yes.
Yeah, okay.
Let's see the telescope that this one orbits around.
That's a good way of describing
This
it.
is the moon of that one.
OK, John.
Yes. Here we are. Well, this is the famous one, isn't it?
It is. This is the Patrick's 15.5-inch telescope, the largest one he's got in his garden. Well, this one's on another equatorial mount, so you can see it pointing up towards the pole there. So you can move it round left and right, and it follows the same arc in the sky that we had with the other one.
Yes, the semi-diurnal arc, in fact.
Good gracious, John, have you swallowed an encyclopedia?
It's a phrase I learned today and I was determined to use it. Which brings us nicely to our questions. Now, here's one from Paul Boswell from New Haven. I have a 3-inch reflector telescope with a few eyepiece lenses, ranging from 20mm to 4mm. What can I expect to see with such lowly equipment?
It's not lowly equipment at all. I mean, the first telescope I've used was 40mm across, and I saw wonderful things with that. I think the trick would be to use the lowest power eyepiece, so that's the 20mm eyepiece. That gives you the lowest power and the widest field. But the moon, the craters on the moon, easy to see with a telescope like that. Jupiter again, which is up at the moment, you've got the 4 Galilean moons dancing around either side of it. You'll definitely see the disk of Jupiter and the belts running across it. Other planets are Saturn in the early morning and Venus. Venus doesn't show much detail though, it's just incredibly bright. It does show a phase, but not much detail on the disk. Deep sky stuff again, there are lots of clusters up there. You've got the Seven Sisters cluster, you've got the Beehive cluster in Cancer, that's a lovely sight, and also the Orion Nebula again. You must have a look at the Orion Nebula.
Now then, this from George Brown at Westeros in Scotland. When viewing images through my telescope, everything appears black and white. Why is it that the Hubble images I've seen are always in glorious colour? Is the colour real or added during image processing?
Basically, for a sort of average amateur-sized telescope, if you look at an object, a deep sky object, like a nebula or a galaxy, there isn't enough light coming through to stimulate the colour sensors at the back of your eyes. You see it in glorious monochrome. Hubble uses filters to take monochrome pictures, and then these are combined in a way to produce a full colour image. So the colours aren't false, they are just through different filters and then put together in a certain way.
Well, that's good to know anyway. No cheating with Hubble. And at the end of that round, Pete, you've scored 28 points.
Yes.
Dr Lewis Dartnell is an astrobiologist.
Hi there, Patrick. How you doing?
Nice to see you again.
Good to see you again.
It's his job to work out if there's life out there and where the aliens might be.
Well, what question have you had sent in about this?
Now then, this comes from Morgan in Taunton, aged 9. Do you think there is life out there like aliens?
It's a good question. It's always the children who have the best questions.
And the hardest to answer.
Yeah. I think so. And I think that alien life or extraterrestrial life is a likelihood. It's probable enough, it's likely enough that it's worthwhile to go out and look for it. But I think there's a distinction between primitive life, bacterial life, that could survive on places like the frozen desert of Mars, And then intelligent life that would have to be complex and big and quite fragile, like a human being. To have intelligent life, the life that might be able to have a conversation with us over radio, it would have to have a planet. Its home would have to be a planet probably a lot more like the Earth.
It's interesting to look at the shift in this, I think, over the time of the sky at night, because this used to be the astronomer's problem. Now it's a biologist's problem.
Quite.
What conditions do you need for life? If you have those conditions, if you have water, liquid water, if you're in the Goldilocks zone, what else do you need? How likely is it that life will begin? And then maybe it will become a sociologist's problem.
I think myself, the key may be Mars.
One of the great frustrations, I feel, is that this is one of the biggest questions, if not the biggest question you can ask. We suspect there may be alien life on Mars, and yet we have not dedicated a mission yet to go and look for it. I know that ExoMars, the joint NASA-ESA mission, is going to go.
We have.
And what is the date for that? 10 years?
2018 looking for launch. As you say, it has slipped a little bit.
If we ever do discover it, it'll be the greatest discovery of all time from every point of view. And I'd love to see it for some... On the sky at night? Well, I'd love to try it. Lewis, thank you very much.